In section 7.4, we're going to solve polynomial equations in factored form. And you can see by looking here on what we are going to cover. So using the zero product property. Before we actually go into the actual zero product property, let's talk about what a factored form looks like. Now, factors. You've done factors way back in elementary school. If I asked you factors of 20, you could tell me 1 and 20, 2 and 10, 5 and 4. Those are all factors. Polynomials can be factored as well. So a polynomial is in factored form when it is written as a product of its factors. So here we go. Standard form, x squared plus 2x. The exponents go from highest to lowest. But if we undistributed the x, this is what it looks like in factored form. If I would tell you to factor the polynomial x squared plus 2x, you would have to give me this. X multiplied by the binomial x plus 2. That's its factors. X, okay, so I want you to understand that x and x plus 2 are factors of x squared plus 2x, just as 5 and 2 would be factors of 10. Now, if I asked you what the factors of the trinomial x squared plus 5x minus 24 would be, you would have to give me the two factors, x minus 3 and x plus 8. Now, today, right now, you do not know how to go from this to this, and that's okay. But you have to understand that a factored form of this trinomial would be these two factors, x minus 3 and x plus 8. So, the zero product property. When one side of an equation is a polynomial in factored form and the other side is 0, you are going to use the zero product property to solve that polynomial equation. The solutions of a polynomial equation are called the roots. So if I asked you to do the roots, it's not the band, it's the roots are also the solutions of a polynomial equation. So let's talk about your core concept. Your core concept is this. Now, before I actually read this, I'm just going to show you one thing. If I said that you had a number multiplied by another number and what you got was the product of 0, what do you know about one of those numbers? One of them has to be 0. So either this number has to be 0 or this number has to be 0. That's what this says. If a product of two real numbers is 0, then at least one of those numbers is 0. For example, this is huge key concept. It tells you how to do everything. If you have two real numbers, a and b, and you are multiplying them together to get 0, then either a has to be 0 or b has to be 0. Notice that this one equation branched off into two separate equations, separated by the word or. This is a disjunction. Remember that? Two sentences with the word or. So example number 1, solving polynomial equations. Notice right here that you have an equation that has two polynomials equal to 0. What you are going to do is, this is your a, this is your b. One of these has to be 0. Either this has to equal 0 or this has to equal 0. Because remember this, ab equals 0. This would be your a, this would be your b. One of them has to be 0. So you're going to take each of these and set them equal to 0. Either 2x has to equal 0 or x minus 4 equals 0. One of them is equal to 0. You now solve both really easy equations. So if I divide both sides by 2, x is going to be 0. Or if I add 4 on both sides, x is going to be 4. So you could say the roots are 0 and 4. The roots are 0 and 4. So you can write this as your answer. X equals 0, and 4 would be your answer. Next, x minus 3 times x minus 9 equals 0. One of these has to be equal to 0, so you would set them both equal to 0. Solve them both. Add 3 on both sides. Now, I'm not showing you these steps because this is 5th, 6th grade stuff. So x equals 9. That means that your answer for x has to be 3 or 9. Doesn't have to be both. The roots are 3 and 9, so either answer can be 3 or 9. Now, if you wanted to plug in 3, that gives you this value as 0. If you plug in 9, that makes this value 0, so it would work. When two or more of the solutions, when two or more roots of an equation are the same number, the equation has repeated roots. So you can have repeated roots. They're the same thing. So let's solve each of these equations. Take each of these, set them equal to 0. Now, these are easy, so easy. Subtract 7. Divide by 2. I add 7. Divide by 2. X, the roots are negative 7 halves and positive 7 halves. Now, something that you can write this as, x equals plus or minus 7 halves. You're going to actually see this a lot more coming up in the future. But if you have two roots, two solutions that are one's positive, one's negative, and they're the same number, you can say plus or minus 7 halves. Something else, that's a little trick that I've heard in the past, if you have each of these, you can take the opposite of opposite of the back, divided by the front. This is the front. The number in front of the variable is always your front. This is always your back. So the opposite of the back divided by the front. The opposite of 7 is negative 7 divided by 2 gives you negative 7 halves. The opposite of negative 7 is positive 7 divided by the front, 7 halves. So the opposite of the back divided by the front. The opposite of the back divided by the front. The opposite of the back divided by the front is a trick. All right, so let's do the next one. Notice that x minus 1 squared would be x minus 1 times x minus 1 equals 0. Well, if we set them both equal to 0, you're going to get the same answer of 1. So this is called a repeated root, what we talked about up here. What is the repeated root? This has a repeated root of 1. So now we can use the zero product property even when we have more than two terms. Here, you'd set them all equal to 0. And by the way, I'm hoping you're realizing very soon that you can just skip these steps and go right to your answers. This is not difficult. So if you solve each of these, whoops, that's not what I wanted to do. If I subtract 1, I get x equals negative 1. If I add 3, I get x equals 3. If I add 2 to both sides, I get 2. So here my roots are negative 1, 3, and 2. All right, so factoring polynomials using the GCF. To solve a polynomial equation using the zero product property, you may need to factor out the polynomial or write it as a product of other polynomials. You must look for the GCF, the greatest common factor of the terms of the polynomial. What is that? It's the monomial. Monomial that divides evenly into each term. So, here we go. In the past, you should have factored out GCFs. For example, if I gave you 5x plus 10, you should have last year taken 5x plus 10 and factored out what they have in common. Here, they have a 5 in common. So you would basically undistribute, which we call factoring, factor out a 5. So if you divided a 5 in both these terms, you'd have 5 times x plus 2. If I gave you this, 3x squared minus 9x plus 12, what can go in all of those? 3, 9, and 12 can all be divided by 3. So you would divide out a 3, and what you would have left would be x squared minus 3x plus 4. If I gave you this, 2y to the 4th minus 3y to the 2nd. No, yeah, that's fine. 2 and 3 do not have a common factor of other than 1. But they both have a letter. So what can you take out of them? Well, you can take out an x squared. Remember, when you divide with the same power, you subtract them. So this would be left with 2y squared, because 4 minus 2 is 2, minus 3. And that would be your answer if you factored out a y squared. You should have done that last year. Now next, in example 3, you are going to factor out the greatest common factor, otherwise known as the greatest common monomial factor. So what you must always do, is first look at the number they have in common. Is there a number that you can take out of 4 and 24? Yes, I can take out a 4. Is there an x in both terms? Yes, if you do not have the same letter in all the terms, you cannot factor out that letter. Now here I have x to the 4th and an x to the 3rd. So you take out the smallest power, which is x to the 3rd. So if you divide that out, this should not be difficult because all you're doing is dividing. You're going to take 4 divided by 4, which leaves you with 1. X to the 3rd, you're taking 3 of them away, and it's x because you should remember, if you're dividing, you subtract the powers. That's why we get x to the 1 right here. Plus, now I take 24 divided by 4, I get 6. Here you're taking x to the 3rd divided by x to the 3rd. Well, anything divided by itself is 1. So my answer is 4x to the 3rd times x plus 6. Let's try another one. Let's just do... No, let's not do that. Let's do 10x to the 4th minus 25x. First look at this and ask yourself, what can I take out of 10 and 25? I can take out a 5. Do they both have an x in them? Yes. The smallest x is just x to the first power, so now we divide it out. 10x to the 4th divided by 5x gives me 2x to the 3rd. 25x, or negative 25x divided by 5x, gives me minus 5. And if you distributed this, if you actually wanted to see if you did it right, just distribute and see if you get your original problem. So why is this important? Because in order to factor some equations, in order to solve them, you must factor them. So we're going to start with A. 2x squared plus 8x equals 0. Now you don't know this, but this is a quadratic equation. You cannot solve an equation with an exponent other than like 1 by getting variables on one side. You guys are so used to, oh, I'm going to do inverse operations and distribute and solve it so I get x on one side. When you're using equations that look like this, when you have something equals 0, you must factor it. So here we go, let's factor. What goes into 2 and 8? 2 does. They both have an x. So my lowest x is an x, so I can take out or factor out, I can undistribute a 2x. 2x squared divided by 2x, that just gives me x. Plus 8x divided by 2x does not give you 4x, it gives you 4, because x divided by itself is just 1. Now we solve this using what we did. We take each of these, we set them equal to 0. 2x equals 0, or x plus 4 equals 0. I divide both sides by 2, that gives me 0. I subtract 4 on both sides, I get negative 4. So my roots, my solutions, are 0 and negative 4. B, 6n squared equals 15n. You must get it equal to 0. You must get it equal to 0. You must get it equal to 0. So I subtract the 15n on both sides. I get 6n squared minus 15n equals 0. You then must factor out a GCF. What can I factor out of a 6 and a 15? I can factor out a 3, and I can take out an n. If you take out the 3n, what binomial are you left with? You are left with 2n minus 5. I now take each of these, set them equal to 0. That would give me n equals 0, and n equals, you can use that trick if you want, the opposite of the back divided by the front. The opposite of negative 5 is 5, divided by the front is 5 halves. Or you can add 5, and then divide by 2, and get your values of 0 and 5 halves. So let's do our last example, which is a real-life problem. You can model the arch of a fireplace using this equation. It's already given to you. Now, later on, you're not going to be given anything. But right now, they're giving you that equation. X and Y are measured in inches. The x-axis, right here, represents the floor, and the width of the arch at floor level. Or I'm sorry, find the width of the arch at floor level. So you want to find the width of this arch. So I want to find the distance from here to here. Now we don't know what the exact answers are, but this is where your brain has to come into play. What is the y value at both of these points? Since we're on the x-axis, the y value has to be 0. We're talking about the x-intercepts. The x-intercepts are when y is 0. So I have to take my equation, y equals negative 1/9 times x plus 18 times x minus 18, and I plug in 0 for y. And now you have a quadratic or a polynomial equation. So the first thing I have to do is multiply both sides by negative 9. Well, if I multiply by negative 9, I still get 0 equals x plus 18 times x minus 18. I now set each of these equal to 0. X plus 18 equals 0, and x minus 18 equals 0. If you solve both of them, you get x equals negative 18 and x equals positive 18. That means your values are both plus and minus 18. That means I go 18 to the right to get my first ordered pair 18, 0, 18 to the left to get negative 18, 0. So the distance between negative 18 and 18, the difference would be subtracting them, would be negative 18 minus 18.